So anyway, I'm just going to switch gears real quick so I can try to keep us back on track here, and talk about some of the SMP work, the status of SMP. I talked about this earlier, so there's a little bit of overlap here. We worked on, in 2012, APL and Goddard worked on this joint research project to add the multi-core support. We used a Leon 3 dual-core CPU in VxWorks. It's an older version of the CFE. I can't remember what version it was. It might have been in the 5 range. And we ported the OSAL to support processor affinity, so we could specify the processor we wanted to start a task on with the OSAL. We changed the CFE core startup code, so we could also support processor affinity. So in the startup script for the cFS apps, we could tell it, run on processor 1, 2, or just float, and let the operating system decide. And we gave the, whoops, wrong button. We gave the code to Steve at JSC to do that, to continue working with that. And we haven't had the resources either at Goddard or APL to do much with it since then. But now, all of a sudden, it's going to be very important to us. Here's some of the upcoming SMP-based work we have. We have this Mustang processor card that I mentioned earlier. It's going to be used on PACE and the PACE OCI instrument, and that's using VxWorks. We want to use CFE with SMP support on that. We have WFirst, which is using the Leon 4 quad core, and we want to use RTEMS with cFS. We have this other project that's kind of a little longer term, this high-performance spacecraft computer. This is going to have 2 quad-core arms. Jonathan, do you know if they look like a single 8-core CPU?
No.
2 quad cores?
Yeah.
And so we're going to need both, kind of the SBN style interface and the SMP work for this. And then other Goddard processors. I know there's a lot of SpaceCube, or a lot of CubeSat processor boards now that are based on the Zinc. And I think it would really be beneficial to have these up and running with something like RTEMS and SMP. So I think what we need to do, I can't claim that I've spent much time in the last year or so thinking about this, because I've just been working on this tiny CubeSat. But I think what we need to do is make sure that we have the OSAL API affinity support correct, and supporting things like VxWorks, RTEMS, and POSIX. We want to make sure that we have any needed APIs in there for interrupt and locking. And I'm not sure if we need anything like multi-core control. I'm not sure if there's any APIs we'll need for things like, maybe migrating a task or something like that. And of course, we want to have VxWorks based on our existing work. We want to have Linux and POSIX support. And of course, I thought I remember hearing about an existing port. There was already multi-core support in Linux. And then, of course, we want to use RTEMS 4.12, 4.11, and eventually switch to 4.12. And as far as the CFE core, we want to continue to work on the processor affinity support for cFS applications, being able to specify what processor you're starting up on. That way it'll let you kind of balance the workload you have. We also need to take a look at one of the things we didn't address with our technology project was looking at the internal locking considerations. I know we do have some interrupt locks in our code, like maybe in the time subsystem. We need to look at that and either remove or revisit how we're dealing with interrupt locks and mutexes in the CFE core code, because we want to make sure it's SMP friendly and we don't cause any deadlocks or have all 4 processors waiting for an interrupt when only one should be.
I think a lot of that's been done. So there was a track ticketing to go, and they were coming up and getting fixed to make them SMP safe.
So that's what the community is working on, probably mostly Joe, right?
Well, a couple different
Okay,
folks.
That's
I'm not
great.
sure if it's complete yet, but we're on the way.
okay. Yeah, I mean, part of this is, I'm kind of trying to get back into this stuff. I've been largely away from it, working on the smallest thing we have at Cudmore. And also, whoops, more. Do we need to do anything like, choose where the CFE core tasks run? The CFE core is started up with this object table, which generally isn't messed with. We just let it start up everything as it needs to. But, my guess is we wouldn't want to mess with CFE core tasks and let them all run on a single core. Do we need any other type of API support in the CFE? But again, my thought is just keep it simple and minimal enough to support what we need to and not try to go overboard on the features. And then as part of that high performance spacecraft computer project, we're starting to look into standards such as power management, and there's standards like OpenAMP where we can run multiple workloads or multiple operating systems even on different cores. And I don't know if it's worthwhile to take a look at some of these standards and see if they apply to what we're doing here. But there are a growing number of open standards that are being worked on in the industry because, it makes sense when you have things like phones with quad-core processors and the low power auxiliary processor to try to manage the power modes and workloads that kind of applies to spacecraft. People envision using these quad-core processors or even 8-core processors where they want to basically have a low power cruise mode to a planet and fire everything up for entry, descent, and landing. So again, feel free to send any thoughts or information my way about this stuff, and I'm working with Dave trying to allocate some more bandwidth for this stuff.
Any other thoughts or questions? This is kind of unfair to Alan because I know so what can we do so it's easier to move a PSP from, there's less to do for a PSP for RTEMS. So it's easier, so once RTEMS has a normal board support package, you get a certain minimum amount of support out of the box.
Yeah, I mean, much like Linux, Linux now, in fact, I mentioned earlier this distribution I'm putting together of the cFS based on the open source releases. And right now what I have, I can, thanks to Joe's CMake system, I can build it on my Linux machine, and I can also either cross-compile it for the Raspberry Pi, or I can just copy it over to the Raspberry Pi and compile it, and it runs. So, a PC running Linux and a Raspberry Pi are pretty far apart in terms of hardware, and yet they're using the same CFE PSP and they run fine. So my goal is to try to make RTEMS work the same way. I really want to have like a out of the box experience for RTEMS like VxWorks does. I mean, not VxWorks, but VxWorks, actually all of them, VxWorks, RTEMS, and Linux. But Linux is the one right now that is easiest to work with. So I'd like to incorporate the support for RTEMS where you could just kind of grab everything from the Git repositories and run the CMake or whatever we need and spit out a working RTEMS cFS image, or basically an RTEMS image with a collection of loadable cFS files that can run on it. And so the more standard an RTEMS board looks, with its BSP, and it has a lot of things it needs out of the box, like the shell and file systems and things like that, the easier it'll be to do that. Common interface for drivers like the UARTs. So it shouldn't be that hard. I'm thinking that, generic Artem's PSP shouldn't be that difficult. They could run on any of the simulators or be used as a starting point for a mission-specific board. Anything else?
Thank you, Alan.
Okay, thanks.